said she said that I have been watching the videos.
That is also me.
Do I actually sit in my room as I watch some
That's like
videos?
no,
but I'm hopeful that you're
I
like
have to listen to something.
absorbing something. I don't know.
I usually set it up.
I just had it in my background and forgot that it was running for like 30 minutes.
Okay, so we are going to start by drawing the slope field for dy dx equal to x plus 1. So I've already given you the derivative function. Sometimes you'll have to find it on your own. But for the purpose of today's homework, I already gave it to you. I believe. Yes, I'm pretty sure I did.
We know how to find derivatives.
Yeah, you guys know how to find derivatives. That's not the hard part here.
How many of these are there?
Notes, 1, 4.
Is that it?
Yeah.
So like, if I put them next to each other, I can fit them on the bottom part of this page.
Now with the tables as well, but we'll see. So what we first need to do is we need to plug in x values and y values, whatever is present in our function, and then we'll just draw the slope at those specific points. So I'm going to go ahead and draw the graph first, because we're just filling it all into a graph. Be terrible. 4.
So we just need 4 points then, or?
Oh no, we're gonna fill in almost the whole thing, but
Well, then
our axes only go 4 in each direction. And of course, you can make a table if you want to, but I find it easier just to go ahead and do the computations at the given points. We'll start with the table, and then as we get more comfortable with it, move into that. So the good news here is that I have no y value present in this derivative function. So all of my slopes are going to be dictated by the x values, which means it's going to go a whole lot faster. So when I'm doing my table, my y column is going to be left empty, because there are no y's to consider.
We actually have to make a table.
No, I already said that. I make a table just to start with, but you're more than welcome to just do the computations for each point on your own. I always like to start at x or y equals 0, depending on what variable I've been given. If I have both, I like to start at the point 0, 0. So then all we do here is we take 0 and we plug it into the derivative function, and the number I get is the slope of the line I'm going to draw at that point. So what happens when I plug 0 in? I get 1, which means the line I'm going to draw has a slope of 1. That is the line I'm going to draw at each point that has an x value equal to 0. So it's going to be the whole y-axis here. And I'm going to draw that line at each of these points.
I like the colors.
I'm going to try and switch colors for each thing that we plug in. But
That's gonna look like
with what? Sorry. Okay, so after 1, we can, or after 0, we can plug in 1 or negative 1. It really doesn't matter. We're going to do both at some point. So I'm going to start with positive 1. What happens if I plug 1 into that derivative function? I get 2, which means I'm drawing another positive slope line that's a little bit steeper. I'm going to go to the vertical line where all my x values are equal to 1, and I'm going to draw that blue line best as I possibly can. Oh boy, it's getting ugly.
I don't like that.
You don't like that? So the
This is
cool
too
thing
many
is,
lines.
I can kind of figure out what's going to happen when I plug in 2, right? It's just going to equal 3, which is going to be an even more steep positive line. So from here, I can kind of generalize that it's just going to get more and more steep the farther right I go.
Oh, well, I did mine.
And you can just keep drawing those more steep lines.
mine's based on.
Because we're kind of just looking for the slope curve that's happening here. So I know what's happening on the positive side. Now I need to do the same thing on the negative side. So I'm going to plug in negative 1.
Looks like wind patterns or something.
It does. Or oceanic, like wave current patterns. What happens when I plug in negative 1? What line has a slope of 0? A horizontal line. That's an undefined slope. So we want a horizontal line because that has a slope of 0. So at all of my x equals negative 1 values, I'm going to have a horizontal line.
I do like it better when we draw on every single one.
Mhm. It just takes forever.
They're literally short, tiny lines.
I know, but when you get a 4x4 grid, that's 64 lines.
No more lines, we're done.
Actually, it's more because technically we have 9, so that's 81 because you have to count 0 in there as well.
No more lines.
Okay, now let's plug in -2 so we can see what's happening over here with our nice little wind pattern current thingy, whatever he called it.
But I'm sure it's gonna be everything.
So what happens when I plug in -2? I get -1. So a slope or a line that has slope of -1 looks like that, approximately. So everywhere that my x value is -2, I'm going to draw that line as best as I possibly can. I don't expect perfection here. I heard that. You said that's a first. And then we can plug in -3. What happens when I plug in -3? I'm going to get a line that has a slope of -2, which means it's going to be a more steep version of this line. So I can just go ahead and draw that. Do we kind of see what's happening here? Yes, my slope curve is looking somewhat like a parabola.
That looks nuts.
Oh.
So it just lets us see the general derivative pattern that's happening with this function. Are we all okay with that?
No, but
I'm having trouble drawing between these lines.
I know, they're rough.
that's what you get, David, for writing.
I do not expect you to necessarily draw like what the pattern is, but I should be able to see the pattern on your paper. Some of them are more obvious than others, and some of them are more complex than others. It just depends. Are we all okay with this one? Let's do another one.
I think they're all gonna look this.
I really love slope fields. I think they're so much fun.
I think it's just redundant drawing all those lines.
Oh, it is extremely redundant. And on the AP test, it'll usually be like, find the slope field that matches this derivative pattern, like that kind of thing. Nothing super crazy. They will not have you, I've never seen them have you draw a slope field. Never,
Well,
ever.
I'm not
the
passing
video,
the AP
it's like
test,
random
so,
lines that they didn't really-
you know.
Yeah. So this time, my derivative function is equal to 2y.
I'm just saying, that's just my fate. Is it always gonna be 4x4?
It just kind of depends. I like to do 4x4 at the least. The biggest I'd ever have you do is a 6x6. But I really hope on homework I just gave you a 4x4.
So we're never gonna have a y value.
Well, here we only have a y value. So it just depends on the derivative function that we were given. So this one doesn't have an x in it, so I don't have to have an x value here. I only have y values that I'm worried about. So I'm going to go ahead and do my table. I always put x, I always put y, and I always put the derivative column. We just leave some of them empty depending on what was present in our function. So here, I don't have any x values, so my x column is going to be empty, which means I'm just plugging in y values. So when I find a slope, I'm going to draw lines in a consistent horizontal pattern because all my y's go horizontal. So what happens when I plug in 0? Because that's always where I like to start.
0.
I get slope of 0, which means that everywhere that I have a y equal to 0, I'm going to have a horizontal line. It just so happens that's going to overlap with your x-axis. You should still draw the lines.
Well, I didn't draw separate lines.
How do you do it like this?
And then I can choose to either go to y equals 1 or y equals -1. It doesn't matter. We're going to do a couple on each side. So what happens when I do y equals 1?
2.
I get 2. So a line that has a slope of 2 looks something like that. So everywhere I have a y equal to 1, I'm going to draw that line.
So y ones are horizontal.
Yeah, because y is a horizontal line. Then I'm going to go to positive 2 and see what happens. 4. So it's an even more steep positive line. So it's starting to resemble a vertical line. Completely vertical is impossible because that would be an undefined slope. So if we see a vertical line, it just means it's a very large positive slope. So that means I can go ahead and draw that here. And I'm starting to see a trend because the farther up I go, the more steep my lines are going to get. So I can just go ahead and draw in the rest of those as very steep lines because that's what's going to happen. I'm not going to go all the way up, but you can. Then we're going to go ahead and go to our negative section. So when I plug in y equals -1, what happens? I get -2, so I need to find a line that has a slope of -2, and it's approximately that red one. Approximately. These are all approximations. But I should be able to tell the difference between a line that has a slope of 2 and a line that has a slope of 4. I should clearly see which one is more steep, so make sure you're paying attention to that. So I go ahead and I draw that.
This is all we're doing on our own.
Yes,
This would be easy like this.
yes. Then I go ahead and plug in y equals -2, and what do I get? -4. So I should be able to tell that this line is more steep than the one that was -2. Again, it's still going down from left to right because it's a negative slope. So I go ahead and I draw that.
Now ours are like a little off.
That's fine, as long as I can tell what's happening. And I know that as I continue to go down, my lines are going to get more and more steep. So I can kind of see what happened here. It's not as pretty as the other one, but I can still see what my wave pattern is doing. Questions, concerns, or issues?
Nope. One more time.
We're good?
We have to draw on it.
You do not have to draw it, no. As long as I can see what's happening.
So would it be,
Well, this one would be weird because it goes horizontal, so it's almost like it's coming in and swooping up and down at the same time. So if I were to draw a pattern, it would look like that and like that. That's what my pattern would be doing.
So if we draw that.
If you drew that, that's fine. I'm not going to look for that. I only care about you being able to do each of these points. Let's do another, and we have 2 more, and then we're done.
How about no more? And we get done.
We haven't done it.
No.
What an astute observation. So the first thing I noticed that's different between this example and the ones we've already done is that my derivative has 2 variables in it, which means I'm going to have to put a little extra work into this graph. Okay, because I'm not going to be able to just generalize along a vertical or horizontal line because I have both variables there. So this one will take a little bit more work and a little bit more time. I always like to start at the point 0, 0 because that's just me. So that's what we're going to do. What happens when I plug in 0 for x and 0 for y?
0.
I get 0, which is what type of line? Horizontal. So I'm going to draw a horizontal line at 0, 0. Then I'm going to pick another point that is immediately next to 0, 0, because I always like to work from one point out. So I'm going to pick, 0, 1. Okay, up 1. So 0, 1. What's that one going to be? 1, which means it has a diagonal line that has a positive slope of 1. So I'm going to draw that. Then I'm gonna pick another point that exists directly next to 0, 0, because I need to fill in all 4 of them. And you just kind of keep working out. So what happens when I plug in the point 1, 0? I'm gonna get 1, because my x value here is 1, my y is 0, 1 plus 0 is 1. So it's gonna have another positive diagonal. What happens when I plug in the point 0, negative 1? I get negative 1, which means that my diagonal is going to go the opposite direction. What about when I plug in the point negative 1, 0? Negative 1. And then we pick more points. So this is why this one takes more work, because I actually have to plug in each specific point. So now I'm going to
All
move,
of them?
huh?
All of them?
Well, you'll have to until you see the pattern happening. And then for the most part, you're okay. But it's gonna take a little bit longer. So what happens when I plug in the point, let's say 1, 1 right here? I get a slope of 2, which is a slightly more steep diagonal from left to right line. What happens when I plug in 2, 0? I get 2. Right? I'm just plugging in points. If I plug in 2, 1, I'm going to get an even more steep line. So I know in this direction, my lines are just going to get more and more steep. So I probably don't have to do a lot of work over there. Right? Because these are just going to keep getting more and more steep the farther up I go. Oh, goodness. Okay, so I know that that's happening because I can plug in the points to prove it. Because I'm just adding positives to positives. So that allows me to focus in some other places. So I actually want to start looking kind of over here just to see what's happening. So what happens when I plug in negative 1, negative 1? Or sorry, negative 1, 1. My apologies.
0.
I get 0, which means that's a horizontal line. I know the same thing's going to happen when I plug in 1, negative 1, because they're going to cancel each other out. I also know that's going to happen when I plug in 2, negative 2, because they're the same number with the opposite sign. So I notice that I'm going to have a diagonal here of just horizontal lines. By seeing that, I can actually see the pattern emerging where all of my lines are consistent across the diagonal. If you don't see it, you just keep plugging in points.
So the ones on the top, we're gonna go up.
Yeah.
And the ones on the
You draw a line.
Huh?
You draw a line.
What line?
Where they're just gonna like start in that middle and go up.
No, you'll see. We haven't filled in a lot of points yet. Okay, so what happens when I plug in 2, negative 1? I get 1, so I can draw that diagonal. What happens when I plug in 3, negative 1? 2, so that one's a little bit more steep. Same thing when I plug in 4, negative 1, it's more steep. Then I can do 3, negative 2 is going to be 1. Same with 4, negative 3 is going to be 1. So I'm starting to see the shape over here. Now I need some of these points because I have no idea what's happening here. So we just keep plugging in points. I'm going to let you guys work through it on your own. If you want to, if not, I'm going to keep working through it up here just to see if we can get our graphs to match. Okay, so start filling in your slope field on your own, and then I will fill it in as well. That's okay. It doesn't have to look perfect because I know it's very difficult. It's hard to tell what I've gone and not gone already. So this is another one that as I see it happening, I see it's just kind of curving out. Not quite, but close.
Basically do it.
That's kind of what I should see happening. And there's almost always a pattern, so I notice on this one that all of my diagonals have, or for the most part, consistently the same slope line. So once you identify a pattern and you ensure that it works, so you should test with a couple more points, you can just start filling those in a little bit faster. Questions, concerns, or issues with that one? Again, the ones with two variables take a little bit more work, but they're still not too bad once you see what's happening. Anybody super confused? Am I good to move to the last example?
Sure.
No, you want the last one. It's actually the easiest one in my opinion. So anytime I'm given a fraction like this, the first thing I should identify is all the places where my slope will be undefined, because I'm going to leave those blank. So how do I figure out where my slope is undefined for this function?
Y equals 0.
Anywhere my denominator equals 0, my denominator here is y, which means any place where y equals 0, which is going to be our x-axis, our slope is undefined, and we're going to leave that blank. So when y is 0, my slope is undefined. So those get left completely blank because we have no information there. What do you think is the next easiest thing to identify? How about where my slope is 0, right? Because that's just where my numerator equals 0. And what's my numerator here? X. So anywhere x is equal to 0, except for where y is also equal to 0, my slope is 0, which means it's a horizontal line. So that's going to be which axis? The y-axis except for the origin, because remember 0, 0, where y is 0, is undefined. We can't have anything there. But all of these, I can go ahead and put a horizontal line. Then I'm going to pick a point that's directly next to 0, 0, because that is just a nice place to start. But I can't pick any points that are on this x-axis because those all have y equals 0, which means I need to pick one of these four. So I'm either picking 1, 1, negative 1, 1, negative 1, negative 1, or 1, negative 1. I like the positives myself, so I'm going to pick 1, 1 first. So we're going to see what happens when x is 1 and y is 1. What do I get when x and y are both 1? I get negative 1, which means that I have a diagonal that looks like that. And that's what I'm going to put at 1, 1. Then I'm going to test negative 1, 1. What do I get there? Positive 1, because negative 1 divided by 1 is negative 1, but I have negative of that, which makes it positive. So my line looks like that. I do the same thing for negative 1, negative 1. And my slope is going to be negative 1. And then I do the same thing for 1, negative 1. And I should get a slope of positive 1, which means that my line looks like that. What shape is this starting to look like to you? So this is actually going to be a circular pattern. Of course, we should check that by plugging in some more points. But that is the pattern that you're going to see. Oh, goodness. So this one's beautiful. And we're just going to kind of fill in from there.
Just gonna draw this.
Yeah. Once you see the pattern, it gets a lot easier to just fill stuff in.
I don't know what's going on.
Best as you possibly can.
This is
Yeah, this was really easy.
It is, yeah, it's easy once you see the pattern because then you just know what's happening. I just plugged in points. So 1, 1 gave me this one. Are you good with this inner circle? Okay, so then stepping out, I know the easiest one from here is going to be 2, 2 because they're both the same. 2 divided by 2 is 1, and then I have the negative of that, so it's a -1 slope. Then I can do 1 and 2, which is going to give me a -1/2, which is that slope, and so on and so forth.
So
Just
what would the line look like though, since it can't touch the x-axis?
well, it can go through the x-axis. I just have an undefined slope at that specific point. So I would still draw a circle as my pattern here. I would still say it's a circular slope field.
Okay.
Because that's the generic shape that it's taking on. And you'll notice that the farther and farther you go out, it still maintains that shape. You just have more points that create the circle.
looks like a square.
Well, it's as circular as we can get on a slope field.
Let's have that slope field and get away.
Okay, so your homework is on Canvas. Of course, if you have some questions, I'm more than happy to continue working on it with you. And then tomorrow we are going to start with Euler's method, which is finding the original equation given the integral information. And then we're going to move into U substitution, anti-differentiation. Huh? And your tests are graded and in Power School. I didn't know if you guys saw that.
Oh, yeah, I saw it. My grade went down a letter.